So hey folks, my name is Samir Sengupta, and I am an AI/ML engineer, and I help companies building and deploying agentic AI systems and automation systems. So today, my talk is all about how you can scale up your RAG application using Kubernetes, but these are the same principles you can use to scale your AI agents or any other automation systems. So first of all, right now, a lot of companies are integrating AI with their systems. In fact, McDonald's, as we talk, they have integrated a chatbot which uses Claude Opus, which is a very overkill model, just for basic query systems. The thing is, most of the companies, they are not, who are integrating these AI systems, are not able to scale their application. Only few companies like OpenAI and Anthropic are able to scale their systems. They are able to handle close to 1 billion users on a weekly basis, while all these other companies are barely able to handle thousands. So how do we make an application or an AI system which can be production ready and can hold under pressure? So since this talk is about RAG application, I believe most of you guys know what RAG is. So if you don't, it's completely fine. RAG stands for Retrieval Augmented Generation, and it has only one job. It makes your AI aware about something which it was not initially trained on. So for example, if you go to ChatGPT and you ask, what's the NVIDIA stock price today? It is not going to give you the response based on its training data. It is going to use some sorts of third-party search API, and based on that, it is going to give you the response for it. This is a kind of RAG application. You can think of it as an example. So a good RAG application has a total of 4 different layers working all together to make it into a basic RAG application. Okay. So there are layers like orchestration layer, embedding layer, vector database, and the inference engine. The orchestration layer is the layer which handles all the queries or all the flow of your entire application. The embedding layer is responsible for converting all your questions asked to the AI model into vectors or embeddings. Then the vector database, which is the third layer, it is responsible to store your all company's information into form of vectors. And you can use similarity search patterns to fetch specific chunks or relevant chunks based on the user query and pass those to the fourth layer, that is the inference engine. By the way, a lot of people get confused between inference engine and a large language model. Inference engine is a way of for you to run a large language model. Okay. The thing is, this specific architecture, it's pretty amazing if only few people are using your application. But as soon as you want to make it production ready, or maybe a lot of people are going to use your application, maybe you have built it for an entire team or maybe for your entire company who are relying on your AI system. At that specific scenario, it is going to face a lot of issues with stability, because the thing is, it is only one system is handling all your queries, which is responsible for embedding, pattern matching, and running the inference engine. And inference engines are GPU intensive. Since a lot of people are asking the questions at the same time, you might get a GPU bottleneck on your system, and it might not be able to handle thousands of users at the same point of time. To fix all these things, you can use something as Kubernetes. So what it does is it divides your application into small scalable microservices or pods. These pods are mostly built with something as Docker. So what it does is it helps you scale your application between multiple nodes. So let's say till now you were using a single system for running your entire application, but now you have invested in AWS for hosting your inference engine. So rather than using your one system, you can use multiple systems connected all together, and it can help you, Kubernetes can help you to make sure that your application never goes down. So there are 2 kind of scaling techniques which you need to know if you are working with agentic AI systems or RAG applications. That is horizontal pod autoscaling and Kubernetes event-driven autoscaling. So what horizontal pod autoscaling does is it monitors your CPU utilization. If it goes beyond a specific metric, it makes sure that it spins up new pods for you. So let's say specific layers like embedding layer and vector search, these are highly CPU intensive. And during these operations, or whenever you are asking a question to your AI model, when the AI is performing this specific operation, these are fixed. These focuses on the CPU more comparatively to the GPU or the inference engine. While when it comes to the inference engine, it is highly GPU intensive. So for that thing, you might not be able to use HPA or horizontal pod autoscaling because it just monitors your CPU utilization. In this situation, you might go with KEDA or Kubernetes event-driven autoscaling. So what it does is it makes sure to monitors your entire workflow or your entire queries in your pipeline, and based on that, it spins up new pods for your GPU cluster. So for example, if only 10 people are using your application, you don't need to run 10 different pods for your AWS server in which you are running your AI model. This way, it can reduce the the inference pods for you so that you're not paying extra for when it comes to your inference engine. It goes the other way as well. If a lot of people suddenly started using your application, it can automatically scale up your GPU pod as well and make sure that your application stays optimal, not just for one user, but for entire production team. Okay. By the way, it is also about the right inference engine. In the industry, we have a lot of different inference engines like vLLM, Tensor RTLLM, Llama.cpp, and there are other inference engines as well. The thing is, every inference engine have their own positives and negatives. When it comes to Llama.cpp, it is used when you are working with smaller quantized models. vLLM is used when you want to use paced attention or you have limited GPU and you want to use it for multiple users. You use Tensor RTLLM when you have NVIDIA specific GPU cluster at your place, at your server end. So why does vLLM wins in most of the situations? Let's say you are building your first RAG application which you are going to deploy into the production section. It's because of the paced attention. It makes sure that it divides your GPU into virtual memory, just like your Windows or Mac OS or in general operating system does. So it divides your GPU into specific pages. So it gives limited amount of VRAM or the GPU for each query. So let's say if you have 12 gigabytes of VRAM with you, it's just an example, and you ask something like, what is the difference between machine learning and neural networks? It might give 10 gigabytes of VRAM directly to one question, which just leaves 2 gigs of RAM for another question. Now, this is going to be a very bad experience for the second person who is using your application. But the thing is, if you used a vLLM, it might divide your VRAM in that specific manner that it can handle multiple questions at the same point of time. It helps utilizing your GPU memory way more efficiently, and it is way more better when it comes to the production. Kubernetes also uses optimization techniques, like it makes sure that if any pods is not working accurately or maybe there is any issue with it, it replaces it with the new pod so that your application stays stable, not just for one person, but for entire production. It is way more efficient and makes sure that it scales up and scales down according to your needs and according to the demands as well. Lastly, I have also built an entire repository for this thing for KCD New York 2026, in which I have showed how you can scale, how you can build an AI-based RAG application using Kubernetes. And if you want, you can use it over here. The URL is given, and the QR code is available over there.